Hi, I'm Jon Bek. Welcome to our Week 4 CIS 117 Hangout and lecture. I got Jason already online. And so as everybody knows by now, my first priority agenda item for the Hangouts is to address any student questions or concerns that have come up. So Jason, have you got anything on your hit list that you'd like to see explored or things you want us to go over this evening?
The only thing I ran into was the doodle, whatever it is. So I believe in the video you use a equals. What's the difference between using an equal and an is? Because I got the same results regardless of which one I used.
Let me go see if I can grab the actual doodle, and let's see there. So let me bring the canvas shell in, and let's change over to the 117 course. And so was this the week 3 or the week 4 doodle you're working on?
The week 3.
Okay. So the instructions are insert a new record resembling the following. Is this the one?
Correct.
Okay, so we're going to insert a new record resembling the following, but replace your name, and also pick one of the states already in the database other than California to use the value of the customer state field, and if you've forgotten what the other states in the database. So let's develop that and see where you're using the is. So let's come up here and let's say use HCIT, and let's start by selecting star from person. Okay. And so we've got a whole bunch of people here, and if we wanted to filter that for people that are only, for instance, from Texas, we would put in a where clause where state equals Texas. And you're saying what is the difference on that and is?
Correct. Because I seemed, let's see, so at some point I was able to use is instead of the equal and was getting the same result. Trying to remember where now. Let's see. Because we end up doing a subquery. And I don't recall if it was where I stated customer state equals and the subquery, or if it was within the subquery where statement where I specified is.
Oh, okay. So if we were to develop this as a subquery, let's see here. And
in the doodle, we used the CIS 117 database instead of the HCIT, so I don't know if that makes a difference at all.
It won't, but let's be consistent here. So let's use CIS 117DB, and in that case, let's take a look. I think it's customers, right?
Correct.
And that, I think, uses 2-character state abbreviations in that table. Yeah. Okay. So, and again, is going to be a single result subquery is what we're looking for. So okay. You can say where state equals Wisconsin, but in the, oh, let's take a look.
Customer underscore state.
Oh, yeah.
You added an extra T there.
Yeah. Okay. But isn't going to cut it. Okay. Let's take a look and see if we can find the T-SQL guide on that right quick. So let me pop up a new browser and say T-SQL is keyword. See what we come up with. There's as. Let's just try it with is. Let me take my look at my notes right quick and see if I have one canned that that uses that. Do you remember an example where we were specifically using is?
I just remember that I was using it with that. I think it was because ultimately it ends up being select all from customers where customer state equals, and then we do the subquery of select customer state from customers where customer ID equals 999. I think I was doing is 999. And they try and run that real quick. No, that's not working. What did I do? All right, I'm not sure where I encountered that now.
Yeah, I'm not quite certain. Now there's the any, and this is actually another database, but there's the any keyword in a subquery, and where we use that is you know, a lot of times we'll say equals any or is greater than any, and so if it matches any value in that, or if it's greater than every value, or if it's less than, you know, or I shouldn't say every value, any value, and so. Otherwise, we get into some fairly complex expressions if we didn't have the any operator. So things like, you know, if we wanted to see if it's greater than any of them, we'd have to go find the max and get this down to a single value. Any allows it to be a list, and so any is really powerful because it's really doing list processing for us. It's going through the whole list returned by the subquery. Otherwise, we can use n. Is it a member? Is it any one member of the list? And the other thing we can do without the any or the n is any place we can make a query that gives us only one and only one value returned, we can use that query as if it was an expression. So if we were doing something where, you know, give me the orders where the quantity is you know, greater than 5, and 5 happens to be the average number. So I'm really saying, give me all the orders that are higher than average. Well, but that average may change over time. In a poor month, we may have average items ordered as 4. In a good month, it might be 6 or 7. And we want our query to be correct no matter what. That's where we would use the subquery, and we would select the average here in the subquery, and then it will give us an expression that is dynamically created, dynamically calculated, and we'll always get the correct one back, even as the numbers in the database themselves change. The query remains correct. Does that make sense?
Yeah.
Okay. All right. So let me take a look and see. I'm looking at my notes, and I am I wonder where I saved that, because I had my notes for the preparation tonight, and I just noticed that all my query code is gone. Not that I can't create it dynamically, but it really sucks to have to do that, because it may slow me down a little bit. All right, well, gone is gone. And so let me grab my older note set. Let's open this, which has all the questions. So the notes I'm working from, so you can see them. Basically, I have written our exercises to parallel exercises in the book. And the reason that I've done that is then when I have give examples or tutor or host the Hangouts, I can go through and solve the exercises in the book, which is what everybody has, is the textbook, as an example, and it should be directly analogous to what you're doing in the assignment that I assign for homework. So let me pop that over there. And let me go and grab my solutions code for the textbook, and then I'll be good to go.
Is there anywhere for us to view those solutions to those exercises for the book?
You know, I'm willing to walk through any one of them. I don't release the materials because one of the things that I agree to as an instructor is that I won't publish their solution sets.
Okay.
But while I can't publish them like in bulk, I'll solve any one of them interactively. So if there's one that you particularly want to see solved, you know, either come to the Hangout, send me an email, or even if it's after the Hangout in midweek, if you post the Q&A discussion, I will go ahead and you know, make a little custom video just for that. Just for that question, and link it right in, and then you'll have it. So, and you can play it back and watch it in slow motion, or you know, go over anything that seems to be a sticking point.
Okay.
Okay, and I think we're week 4. I think we're chapter 5. Are we not?
That's the chapter we'll be doing for this week.
For the upcoming week. Okay. All right, so let's take a look at this, and if you don't have any particular questions, I'll just solve some of these in order, or if you want to cherry pick them, you know, I'll do any particular ones. Have you looked at the exercise set for the coming week?
Not yet. I just
Okay.
started reading that chapter today.
Okay. So we're starting to get into more sophisticated SQL. We're doing subqueries, and we're starting to do joins. And joins are the real power, because having normalized our data structures so that we don't have duplicate data, we've kind of broken things up. So we might have all the customer records in one place, and we might have the records of what they bought, the things they have ordered, in another place. If you want to then link the two together, we need to do a join. That's the most common purpose in doing a join. So we're going to be doing some of those. And there are some important concepts in joins. One of them is, and we can almost do that. Let me see if I can bring up the whiteboard for just a moment. If I change the desktop sharing. And let's see, here's a whiteboard. Okay, so there's our whiteboard. So you remember the old Venn diagrams that you did as a kid in elementary school math, and then you did the, you know, this is the intersection and those kind of things?
Yeah.
Okay, so we can understand joins through a Venn diagram. If we want equijoins, an equijoin between two tables. Means it's where the two table records match. Both sides are present. It's the intersection. If we have a left join, it will give us every record that is, so if we call this table A.
Just so you know, I only see a white screen. I'm not sure if there's anything you put up yet.
Oh, you're not seeing the share. Thank you for letting me know. Let me see if I can figure out what's going on with that. Well, I'll tell you what we'll do. Share screen, whiteboard. Are you seeing that?
There we go. Yeah.
Okay. I think it's because I started it on my second screen. Okay. So if we have table A and table B, and we're going to do what they call an equijoin. We can do an equijoin by just using the keyword join, or we can say, where A dot key equals B dot key, where the two equals that we're linking them together. That's just the intersection here. If we do a left join, that would give us everything in the left-hand table. The left-hand table could be either A or B, depending on which we specified first. The first one's on the left-hand side. The next one is on the, so if we say, join A with B, then it's going to be a left join. That will give us everything in A, but only the things that match in B. Okay, so the other thing we could do is we could say, well, give me a right join, and that's going to be everything that is common between the two plus everything that is in B that isn't in A. Okay, and it's important to use the right kind of join for the right job. If we think about it, one of the things that could mess you up is, let's say we're talking about customers and orders, but some orders may not have been shipped yet. If we were to join these on a shipped type key, you would have, you would miss some orders that way. Or let's put it another way. Let me think. What would be a good way to mention this? Okay, so I want all the customers, whether or not they have any orders. So if B is my orders table and A is my customers table, I would left join because some of the customers have not, they've opened an account with me, but they haven't ordered anything yet. Okay, so that would be an example of where you'd want a left join. What would happen in the case where I said only give me an equijoin, where there are data linking the two tables, so I would get this intersection again? Some of the customers would not be listed. And if I was under the assumption that I was working from a comprehensive list of customers and looking at their orders, it would lead me to faulty business decisions. So the other thing that would be interesting is to do it the other way around. So let's do all the orders, whether or not there is a record in the customer table for them. Now, should it be possible that there is something that's ordered that was not ordered by a customer? That's kind of nonsensical. It shouldn't exist. But can things happen in bugs in poor code, poor logic, that can happen where a order is created and the customer no longer exists or never existed? So we orphan the order. That would be important, not probably for our business people, but for our IT people to do a little bit of cleanup on our database. And you can see why it could have real impacts to the business. For example, let's say we encumber our inventory once it's been ordered. So in other words, if a person has ordered it, we don't sell it twice. If we had items if we have a program that is erroneously booking items as ordered, but not properly associating them with an existing customer, then we could have products that are in our warehouse that we can never actually sell and receive revenue for, which are being reserved by our sales system or our shipping system. That would be bad. So, left join, right join, and an equijoin have their places. We need to understand which to use in order to get the desired result. So, a little mini lecture on that. I'm going to go ahead and kill this whiteboard now and put the screen share back to my primary desktop. Okay. All right. So with that in mind, let's take a look at our first parallel question, which says, for each order, list the order number and order date along with the number and name of the customer that placed the order. Okay, so we were going to understand that the order date is going to be coming from the orders table, and yet the name of the customer is not going to be duplicated in the orders table. Only the customer number is going to be there. So we're going to have to join this over with the customers table in order to get that. The parallel exercise that you guys will be working on for homework is for each person, and this is the HCIT database on the right-hand side. For each person, list the patient ID, last name, first name, admission ID, and admission start date of every hospital admission on record for that person. So one person may have many hospital admissions, or they may have only one hospital admission. It's even conceivable that we have a person on file that has not yet been admitted to the hospital, kind of hopefully a brief duration thing. So they just filled out their admissions paperwork, but they have not yet been processed. So they, for a short period of time, they exist in the person table, but not in the admissions table. And then we're going to sort it by last name, then first name, and finally by admission start date. All right, so let's take a look at how we do the parallel exercise. For each order, list the number, and let's see, that I bet I know, and let me just double check. I think I know why my notes didn't look right to me. So this is chapter 5. I think I made my notes for the chapter 4, so I probably was filling out that for the week 3. Okay. All right. So, but yeah, we are in chapter 5, so this is where we belong. Okay. All right, so I'm just going to clear this out and start a new query. Nope, don't save it. And new query, and let's use tal. And let's start by working with the orders table. I like to build my queries starting with select stars. Okay, so I see I have my order num, order date, customer number, and let's get both queries on the screen separately for a second. And let's say select star from customer. And this is a really nice feature of the SQL editor, that we can have both query results. So these two are separate query batches that have run, and I see both results in separate frames. I can see what I have in common here is that the customer number is going to link these two together. So I could manually, I suppose, come through here until I find a match. And so customer 126 is Toys Galore. And if I would look over here, I would find out that they had an order number 51608 that was on October 12th of 2015. And then I can go and match these. These happen to be sorted in order, but you look, there's another one that's out of order for the also Toys Galore from 3 days later on the 15th of October. Okay, so one customer can have many toys ordered. And so what I need to do is somehow meld these two queries together so that I get the result as if those tables were glued together as one big table. Okay, and so what I need to do is I need to select, what did the query tell me? I needed the order number and the order date and the customer number. And it's going to be from customer, but it's also going to be from orders. So I list all of the tables that I want to draw from there. Now, in some cases, in my selects, I may have duplicate field names because they may have the same field. So if it does, then I would have to be less sloppy. I would have to say, okay, which customer number are we talking about? Are we talking about the one from the order table or from the customers table? Okay. So order num, order date, and so let's say we want this from the orders table, orders.customer num to make it explicit. And I also wanted to add in the customer name, and we're going to get that from order, and I guess it's orders, isn't it? That's why it's complaining. And here is the join criteria. So this is an implicit join where orders.customer num is equal to customer.customer num. And if we've done that right, so now if we were to order by customer num, for example, now you can see that there are 2 orders from customer 126 and 2 orders from customer 586, Almonton General Store, and which orders those are. Okay. So that is a simple explicit join using the where clause. So I didn't use the explicit word join, so I should say it's an implicit join using the where clause. Oops, undo. Okay, let's take a look at our next one. So for each order placed on October 15th, 2015, list the order number along with the number and name of the customer that placed the order. Okay. Now I notice that this is using, again, the customer and the order numbers. So since I've just worked with a join that does that, these I can turn on and off. This is my equijoin. And let's think about this. Do we need an equijoin here? Yeah, where customer num from orders is equal to customer num in customers. So that's still an equijoin. And we're going to need to, let's get rid of the order clause for a second. And let's see here. Do I have the order num? I do. Do I have the customer num? I do. Do I have the customer name? I do. So there's the general solution, but I need to get those for a specific order date. Well, we already know how to do that. It's in the where clause, but wait, we already have something. We have this in the where clause already, but we know how to add an additional clause with a Boolean where it also, at the same time it meets that criteria, it also has to meet the second criteria, and we're looking for order date is equal to, and I think the date they wanted was October 15th of 2015. And there it is. Okay, so we've got 1 order by Toys Galore and 2 by Almonton General Store that match that criteria. Cool. Okay.
Quick question.
Yeah.
How many different ways can you format the date? Because I see you use slash there. I know you can use dash.
There are several, and the other thing that I'm being a little bit lazy, I gotta admit it. This is a string expression, isn't it?
Oh, yeah.
And so I am lazily depending on the fact that SQL Server does a lot of implicit type conversion for me, because it will go and look at what is order date. And if we look at order date on the orders table, so we come over to the table and look and see how that field order date was actually created. Okay, so here's order date, and it is a date type. It is not a string type. So when I compare two different data types, if you've had a programming class, depending on the languages you've learned, you may have learned that you have to do an explicit type conversion or explicit cast. In some languages, it does an implicit cast. Well, here, because it happened without my having to do, and there are explicit cast operators that you can use, and in some cases you will have to, but SQL Server automatically looks up, if you're being lazy like I am right now, it will look up and say, do I have a conversion function that will convert a string into a date or a date into a string? And it says, yes, I do. So I'll go ahead and assume that that was what is implied, and it did it for me. Isn't that cool? Now, the only time that's not cool is if you really didn't want it to do the implicit conversion and you're doing something silly like comparing things that really are trying to join or compare on things that really shouldn't be joined or compared, apples and oranges, then you can come up with some very weird results that are certainly not correct, but you might not notice them until you've already made business decisions based on them. That would be bad. There are a number of date functions and date arithmetic functions, and also a notation for notating things that are in date. The other thing in date formats, the other thing that is going to matter is when we created the database itself. So that would be, I think it's at the database level. If we go look at the properties of the CIS 117 DB, one of the things that we will find there in the properties is the collation order. And the collation order is going to have to do with things like dates and date sorting, and also whether it is case sensitive and how it is comparing strings. There are different possibilities for that. So how you define that is going to impact things like your dates. Let me see, let's just take a look. It's been a while since I've looked at it. There may be some specific date related properties in the setup of the database, and that really belongs to like a CIS 107 type class, a semester length, where we go into the design, or in this case probably one of the system administration and database design classes that would be more like at an intermediate or advanced level. We don't really touch on that too much in 117, but it's a great question, so it's worth looking at. Yeah. I think if you're interested, if you go look at the SQL Latin 1 collation order, you'll find some interesting things having to do with the way that sorting and dates and things work. And there are several different types of date formats among different relational database systems and non-relational database systems, and it is one of the biggest headaches trying to figure out if you have to convert from one to another. It's always the date types that are going to be the hang-up. So great question.
Thanks for answering.
or evading it skillfully.
Well,
I'm not sure I quite answered it for you, but
you kind of told me where to go look. And
well, and we are going to get back to it. I promise you this, because one of the things we're going to be working with at some point is date arithmetic, and so you need to know the number of days that elapsed between two dates, and so we need functions that will do date arithmetic. And date arithmetic gets fairly sophisticated because, well, first off, how many days are there between the 1st of February and the 1st of March? That changes every 4 years, right? Leap year.
Correct.
So your function has to take that into account, and then there are other things to consider, such as what if you want the number of elapsed business days, now we need to get into some hairy things about what are we counting as business days? Is that every Monday through Friday? What about holidays? What's the holiday schedule that's observed for your company? Yeah, and so it can get into some custom functions that you may end up writing, or more sophisticated stuff. But yeah, date arithmetic and calendar work gets kind of interesting at times. But it's important, very important, especially, so many of our businesses, almost every business has customers, right? And
Yeah.
so dates and customers, that's peas and carrots. They always go together. There's always going to be some calendar work to be done. Whether it's guaranteeing that they get, response or shipment or whatnot within a certain number of business days, and service level agreements, or all kinds of things. So yeah, we will be playing with it a little bit more, but not so extensively as to make you nauseated by it, but hopefully enough to get your curiosity piqued about what you can do with dates and why you would want to do that. Okay. All right, so if we take a look, let's see, the third homework question parallels the fifth question in Chapter 4 on the TAL database, and it's telling you, use the exists operator to find the number and name of each customer that placed an order on October 15, 2015. Okay, so let's see here. Let's start this way. Here is a query that says select star from orders, where orders.customer number equals customer.customer numbers. Let's see, in order to do that, we got to have and order date equals 2015. I'm getting my head ahead of myself here. Let's just say this to begin with. Okay. So these are all the orders from October 15th, 2015. And what we are looking for is, we want to select the customer number and customer name from customer where these orders exist. Okay. So let's take a look at the other half of the query. We started, I always like to start with select star from customer. So I got my two queries going here, and the splitter bar, oh, there it is. Okay, maybe a little more. So here we're looking at customers. Here we're looking at the orders just for 10/15, 2015. Okay, and what I would like to do is link these together again, but only where these records exist. And so there's an exist keyword for that. And what I can do is I can take this whole expression that gave me the results, and we're going to make this into the subquery. And this is kind of the magic of making subqueries. You take a query that you've got that's kind of working, and then we're going to wrap it up as the selection criteria, as the criteria in usually in a where clause. Okay, so we're going to select. Now we don't want star from customer. What did we want from customer? We actually just wanted the customer number, and we wanted the customer name from customer, and we only want that where exists these records. But the problem here is, do you see that we haven't joined these two together? And we were joining in the where clause. There's another way to do it, and that is we can join from the outside in, or we can join. See that this is going to be the inner query, the one wrapped inside. We can join from the inside out. And so The way we join from the inside out is we put a little bit more in the where clause on the inside one. And so we're going to say where orders dot customer num equals customer dot, if I could spell, oh my goodness. And, okay, so here the join is being done on the subquery, and they're going to be joined where these three records exist, and let's go see what the result is. Okay. Now, why did I only appear to get two results? Let's go back and look at this again and analyze that. So I'm going to split that subquery back out into a separate query for a moment. I'm going to drop out the join and the and let's just run that. Okay, so notice this is both for customer number 586. So these are kind of they're dropping out of the mix. So let's run this whole thing again, get both of them up. Oh, separate the batch. Now let's run it. Now I've got two results. Okay, so we see that these are just giving me the customer number and customer name. And the reason I had customer number twice here is because there's two orders. But I don't care how many orders there are. I'm only looking for the summary roll up here of, customer number and customer name were in there, not how many times. So I don't want it to print customer number twice for 586. And indeed, by doing it this way, it eliminates, so this query goes with this query result goes with this first query. And so I am answering the question. And what was the question? Use the exists operator to find the number and name of each customer that placed an order on October 15, 2015. So the fact that this customer placed two orders on the same date doesn't matter. Once they count, they count. The duplicates don't matter because I'm just using the exists. If it exists, it exists. It doesn't matter that it matches the exist criteria twice, once, 100 times. As long as it matches once, it gets in once, and it's going to be uniquely there. So that's a little bit different, and it takes a little time to wrap your head around this one because our join is happening from the inside query to the outside query. And most of the time we're used to seeing it the other way around, but you can go either direction. Okay. So there's the exist. Let's take a look at our next exercise. So our next exercise on the actual homework says for each admission in the admissions table, list the patient ID, first name, last name. Well, we know that first name and last name don't come from the admissions table, so we're going to have to join that with the person table. The admissions start date, primary diagnosis code, and primary diagnosis description, or the output by admission start date. That problem that you guys will be working on independently is going to be comparable to this exercise, TAL number 7 for chapter 5, and that is for each order. So orders come from the orders table. List the order number, order date, item number, description, and category for each item that makes up that order. Okay. Now, if you think about it, this is actually going to be more than two tables. If we look at the fields that we're asking for, we now need to join a third table. Wait, can we join a third table? Yeah, you can join a third table and a fourth table and a fifth table. What we will learn in future SQL classes is that the more joins we do, the more expensive the query becomes in terms of processing time, CPU time. And so this is the result or the consequence of doing a high degree of normalization on our data. Normalization is good, but it's important to understand that it does come at a consequence or a cost, and that is to put things back together. It costs us joins. And so we need to think about strategic denormalization. And again, you'll cover that in a database design class when we actually do the design of the tables ourselves. We think about why we might want to not fully normalize or denormalize a table just a little bit. In general, though, it's rare for us to have to join large numbers of tables where we take that kind of performance hit, but it is something to be mindful of in our design. Okay, in generally speaking, that what we're going to learn at the CIS 117 level, if we talk about normalization at all, is you want it fully normalized, or at least third normal form. And one of our 2 extra credit exercises this term that take us into some of the stuff we don't have time to talk about in the normal class. One of them is a database design exercise that you will learn a little bit about normalization. That's worth 5 points if you want to do that exercise as extra credit. The other one is another interesting field that you might enjoy, and that is geographic information systems work and visualization. So that's another fun alternative. But let's take a look at number 7 and how would we build that. All right, so let me just kill this, and let's do a new query. Clean things up a little bit. All right, so let's build this one by taking a look at the tables we likely have to use. Let's select everything from orders, and let's select everything from order line. And let's select everything from item. Run those 3 batches, we'll get 3 results. Oh, order line, am I on the right? See, tal. Oh, I'm looking at the wrong database. Tal, did I? Yeah, order line. Let's use tal. There we go. Now we have happiness. Okay, and this helps us to see how these tables all fit together. Let me abridge some of the results. Okay, so in our orders table, we have the order number, order date, and customer number. But if we want to get things like the price that was quoted, or the quantity that were ordered, or even the item number, I got to go over to the order line. So it's a line item out of an order to find out what the line item was. And of course, if I want to get the item description, any of the details there, I got to get that from the item. Now let's take a look. What did the problem domain, the problem statement, tell us we needed to provide? So we needed to provide the order number. And the problem with order number shows up in more than one of these tables. So which one do we want? Well, the one it's most native to is the orders table. So it's orders.ordernum, and then let's get the order date. And the reason, now it would be okay for me to fully qualify this. I could say orders.orderdate. There's nothing wrong with that. I don't need to, because it's not ambiguous. It's not duplicating another field name that's found in more than one table. So let's get the order date, and then the item num. But item num is another one of those that's found in more than one table. What's it native to? It's native to the item table. So let's grab that one. and the description, and the category. Okay. And where are we going to get that? Well, let's see. We use the orders table. We use the order line table. And we use the item table. Okay. And then now we have to talk about how are we joining these three tables together. So how do we link orders to, let's put a where clause in there, and let's put these tables down here again. We want orders, and we want order line, and we want order line, and we want item. So if A gets linked, if this is A, if A gets linked to B and B gets linked to C, then I will have a neat linkage all the way from A to C. Okay, so here's how I'm going to build that. I want orders dot order number, that's the primary key identifier on that table, is going to equal the foreign key in the order line table of the same name. So order line dot order num. Oh, get rid of that space. It's not going to love that. And then order line dot, and what is the primary key on the order line table or the item table that we're linking to is going to be the item num. Item dot item num. And now those tables are linked up in that query. We should be able to get rid of those. And let's give that a whirl. Enter syntax here. Where did I get? Not into batch. That should be a comma. Now it's happy. Nope. Oh, need a conjunction there. Where A links to B and B links to C. Now it should be happy. There we are. Okay. Now I'm not doing any additional filtering, or I would put an and there would be additional constraints, additional filters here. This is just an equijoin. Now think about this. This table A equals that table B, and this table B equals that table C. If there are any extra records on any of these tables, they're going to be dropped out of the query if they don't match on these key relationships here. Now, there shouldn't be any of those, but shouldn't be doesn't mean that there isn't if there have been data integrity, referential integrity errors. So it's something to keep in mind when you're using an equijoin. The other thing is I have had students that habitually use the left join for everything. And the problem there is, again, you need to think about, do you want to include tables that have null entries in the secondary table? And that's not a good assumption. So there shouldn't be just one default, you always go to it type solution here. You really need to think about whether or not the equijoin is what you want, or a left join or a right join is appropriate to the situation. Very often, we're going to be using, probably most often, the equijoin. But again, I want you to stop and think about it before you just jump in with it. All right. So the other thing I would mention to you is when you go through a lot of work to build table joins that are more than 2 tables long, what you might want to do is save it off in your notes. And what you might also do is, instead of selecting the specifics, you might just say select star. Now this is going to give you some duplication because some of those fields, like the order num, live in more than one field. Let's see what that looks like though. So notice here's order num, And here's order num again, and it's identical. One is from the orders table, and one is from the order line table. But what is nice about keeping this kind of general query around as a template, this does the join of all those three tables. Any other query we might have to do in the future, you can just pop that in rather than having to build it up like we just did. And you've already got them joined. All you need to do then is change your selection criteria and then add in your additional filter criteria, and it makes it really easy. Certainly for table joins of 5 or 6 tables at a time, every DBA I know, once they have written it for the 4th or 5th time for their employer, they start caching off a general template like this for joining the tables that they work with, joined up frequently, and that way they can just use it as a starting place. As a matter of fact, later we'll learn that there is a sort of database object we can create for those things that are used all the time together. That's called a view, and we can define a view, and it is actually a query that is materialized to make it look like it actually is a table, and then we can go hit that table as if it actually exists as a table, and that makes things a little bit more convenient for us. It comes, again, at a performance cost, so we ought to think about that, but a little foreshadowing of what's coming. All right, I think we got time to do 1 or 2 more. So let's go ahead and clean that up. And let's go back in. Where did I put my document? And let's take a look at our exercise 5. Says find the patient first name, last name, patient ID, first name, last name, of each person that has been diagnosed with non-pneumonic Legionnaire's disease, also known as Pontiac fever. Order the results by admission start date. Gosh, so you're going to have to join. We know that patient ID and first name and last name is in the person, and a person has a patient ID, but the patient ID, we're going to have to go over and join that, figure out how to join that with the diagnoses, and then the diagnosis code. How do we look up the diagnosis code to get these descriptions? So we're going to have to join a couple different tables. So again, multi-table joins. This one is comparable to TAL number 11, which says find the number and name of each customer that currently has an order on file for a rocking horse. Now, we know that the rocking horse is over in the item description, but then there's the order line table that holds the orders, and of course the customer table holds the customer name. So there's at least 3 tables involved in this, okay? And if you look in your textbook, one of the things you'll find is there is a database diagram, an entity relationship diagram that shows how the tables are all linked together. And that's a very handy thing to be working from, or to keep, mark that page in your textbook that shows the ERD for TAL, and then you will be able to work with that. And I think I have published an ERD out there for the HCIT database, and if I haven't, whoever's watching this recording, remind me, and I'll be more than happy to put the HCIT entity relationship diagram that shows sort of a visual of how the tables are all linked together. That too can be useful in making it easier to do this kind of work. All right. So let's see what tables we're going to need for TAL exercise number 11. Okay, so we know we were going to use the customer. And we knew we were going to use orders. And we know we're going to use order line. And then to get the item description, that rocking horse, that has to come from items. And let's kind of see. Bet it's order table and not orders, right? And item table and not items. Oh.
You're missing your from.
Yep. Thank you.
And also in the second one. Yeah.
There we go. All right. So if I
Item.
oh, for crying out loud, Pratt, be consistent. Either name them plurals or name them singulars. All right. So there's our customer number, our order number, and what we're trying to figure out, how do we trace to get all the way from customer name to the item description. So here's our customer number and the customer name. So this will give us our customer name. The customer number will link to the order num, and then the order num links to the order num in the order line table, and then that gives us the item number, and the item number links to the items database, or the items table, right? Okay, so just to recount that, to go from the customer table to the order num, I use the customer number. Primary key here, foreign key here. Then I go from the primary key on the orders table, that gets me into the key on the order line table. That gives me the item number, and the item number links to the item table, which gives me the description. Okay, so it's from A to B, from B to C, and from C to D. So we're going to traverse a 4-table join in this one. So let's start with select star. That's fine. And we're going to do it from customer. We're going to do it from orders. We're going to do it from order line. And we're going to do it from item. And how are we going to get there? We need where, and let's kind of abbreviate this so we can see the logic. A dot something equals B dot something, and B dot something equals C dot something, and C dot something equals D dot something. Now we just need to go and say, what are our A's, B's, C's, and D's? Okay, so we're starting with the customer table, and on the customer table, the customer number is king. That is the key. And we're going to link that to the orders table field of the same name. Now, these fields don't have to be designed with the same name, but it really is a best practice if you're talking about the same quantity, the same entity describing the same thing. We hope to name them the same thing across 2 different tables. Occasionally that doesn't happen, and so it isn't a given that it's always going to be named the same, but most of the time that's how it's going to work out. Okay, that's by intent. Okay, there's our A to B. Now we need our B to C. In this case, the customer table, or excuse me, orders table, John. It's not going to be the customer number that we're linking on in this case. It is going to be, let's see, we're going from orders now to order line, and so that's going to be the order number. Okay, and now from C to D. So back to order line, and now I'm talking about item numbers. Okay, now I haven't solved the whole thing yet, but I should have a working join. This is going to give me all the duplicate table, duplicate column names, and the basic join should be working. Good, I tested. And it says incorrect syntax near the select star from customer orders where. Huh, I don't know, I must have not had the whole thing selected when I ran it. I may have had something highlighted. Yeah, so there was no bug there. Okay, so this is giving me the whole mess, but again, what was our focus once we had them joined up? Find the name and number of each customer that currently has on order, an order on file for a rocking horse. Okay, so I need to add another filter criteria here, and the rocking horse description name that comes out of the description field. Okay, so this is giving me, in essence, the solution, but I haven't trimmed it down to only the required fields. And anybody who's had anything turned in and graded, you know that I penalize if you give me less than was required. I also penalize if you gave me more than was required, if it was specified that there was a specific requirement. And so let's go take a look. What did we actually say we needed from the way the exercise was stated? So we need the customer num, but that's ambiguous because it appears more than one place. So let's get that from the customer table. And again, if you want to go through the trouble, it's perfectly okay to specifically name each table. So you could always say table.field name this, table.field name that. It's just a lot of typing. Okay, but it's not incorrect. I'd certainly accept it and give it full credit if you fully qualify all of your field names. It's just exhausting. And then we want the customer name, and let's see, was that it? Check our statement again. Find the number and name of each customer. Okay, so it doesn't even have to show us the rocking horse. It just has to give me the number and name of customers that have a rocking horse on order, and extra comma, and there it is. So there are the customer's number and name for all the customers in the database that currently have a rocking horse on order across a 4-table join. And now you can start to really take to heart why I'm saying that once you've gone to the work of getting 3 or 4 or 5 tables joined, you might want to save the base query as a template for future use. And I think we're 8 minutes over time, and so thank you for your patience. Jason, did you have any other questions before we sign off that you wanted to ask, or anything that this raised that you wanted to look at?
The only question I have is probably outside the scope of this class.
If I can answer it, I'll be happy to.
Basically, as far as front-end access to SQL, what programming language do you usually recommend?
Now, when you say front end, you're talking about for the application side, or perhaps from a web server that's going to be serving up the results?
Correct.
Okay. It really, I think what you will find is there are suites that are most commonly coupled together. It doesn't mean you can't mix and match, but for instance, if you are being driven by a SQL Server backend, so you're on a Microsoft platform on the backend, it's very common to use an ASP.NET platform on the web server. to serve it up as a front end. And if you're doing a client server where there's no web piece involved, but somebody's PC is running a dedicated application that connects to a backend database, then you would use one of the .NET languages very commonly. Again, not at all exclusively, but very commonly, you would use Visual Studio as your development environment, and you might do that. You could do that with C#, you could do it with C++, you could do it with Visual Basic. A lot of that is going to depend on your market and your clientele. In Fortune 2000 companies, they still use a lot of Visual Basic in Visual Basic.NET because the learning curve is fairly easy. You can use tools like LightSwitch and like Link to put a lot of your query logic right into the application. So that's one way to do it. If you are building to a backend database that is, for example, let's say a MySQL database, then very commonly you might use Eclipse and the Java language, or for applets. If you are writing web server code, you could use JDBC and JavaScript in the client piece, and then we start to talk about stacks. So you're referring to the idea of I have a database layer and I have a web layer and I have a client side layer, and so we talk about stacks like LAMP. LAMP, we tend to talk about it's Linux, Apache. So a Linux operating system running Apache web server with MySQL, and then you would connect to it with something like PHP or Perl or Python. If you're talking about a SQL server, we tend to use the ASP stack. So it's going to be Windows and IIS. And then the client side is either going to be JavaScript in a browser, or it's going to be served up, on a fat client using some sort of ASP .NET framework. Could be a VB language or a C# or C++ language. Really doesn't matter. I don't know. Is that kind of answering your question?
Yeah, absolutely. The reason I ask is just currently. Where I work, the current database administrator, he's kind of been put on limited time, so I'm trying to learn all this to hopefully take that over. And so he has front-end applications I believe he's built in Visual Basic and then compiled with .NET. Does that sound right?
Yeah, .NET is the framework, and the framework in this case can be used by many different languages. So you can if you take my CIS 119 class as an example, we're learning Visual Basic using Visual Studio as the development environment. That same development environment can be used to create C# languages or programs, or C++ programs, and the .NET framework are all the functions that make your life so much easier when working in a Windows environment. So you could call a form or a control in a Windows form program, and it doesn't matter whether you're calling it using the VB language or you're calling it using the C# language. Use whatever .NET language you like. You can even use Python. Actually, Iron Python is a great environment for building in ASP. But the underlying framework is the same. So at these different layers of the stack, you can mix and match. I could pull out one piece and put in a different piece that provides that stack. So for instance, the web server we were talking about was Apache in one case and an IIS in the other. Is it possible to switch that out and still keep the other components of the stack the same? Increasingly, that is possible. They're at the inception, the stack tends to be more tightly coupled. But there are a lot of things now that you can run. As a matter of fact, one of the very interesting things about what Microsoft has done with the .NET framework is they, some time ago, finally surrendered and said, look, we really do need to make this open source because the entire world does not run on Windows much as we would like them to. And so you can actually run .NET Framework using something called the Mono project, and run it on a Linux machine running Apache. It runs very, very nicely. The biggest problem, I think, if you were going to do a lot of strategic development in Mono, is that they always tend to be running a little bit later with respect to the latest version of the .NET Framework release, just because it takes time for non-Microsoft people to port that all over. It's not, it's not Microsoft's core, and so it's like, well, here you go, guys. Here's the open source spec. Lots of luck.
Okay.
So a lot of times you do that as a secondary platform, or it's a great way when you have to, for various reasons, support different hardware platforms. It gives you a way to do it without having to duplicate all your skill sets, because you can imagine when you get somebody who is a real guru, a real genius when it comes to writing on the LAMP stack, they may not be so sharp in a .NET Framework world, and the same thing is true in reverse. And so if you have customers, let's say you're a company and you provide software services or things to both, do you want to have double your staff so that you can develop your product twice, once for Linux and once for Windows? Or do you want to try and use some of these leveraging technologies that says, oh, well, if we went the Mono project, maybe we don't need a full duplication of our staff. We need a couple of Linux gurus, but mostly our developers who are developing in .NET Framework, they can develop once and we can sell it or move it into two platforms. So there are some of those kinds of considerations.
Got it.
So devil is always in the details. It sounds like you're a small shop. If you had one guy who is doing both the web stuff, both and the development and the database stuff. And one of the things that I encourage in my students is they say, well, what language should I learn next, professor? What technology should I learn next? And my answer is always, I want you to be a guru in one, but I want you to be completely fluent in a total of 3. And I don't want them to be overlapping on the same level of the stack. So, I mean, it's fine if you really want to be a Oracle guru and a SQL Server guru and a MySQL guru. That's fine. You are 3 times a database analyst. That's great. But the thing that is going to give you the most flexibility in your job as far as promotion, the thing that is going to keep you at a job longest when everybody else is getting downsized, is that you can do 3 different layers. And the thing that is going to get you out the door soonest when you have a new opportunity for a higher paying job is that you are not a one-trick pony. So I don't want you to know 3 databases and you are just a database guy or just a database gal. I want you to know a database layer. I want you to know a programming layer, okay? And I want you also to know a markup layer. What do I mean by markup? Web languages like HTML are not logic languages. They're used for the display and the layout. The hypertext markup language, it's right there in the language. It's what helps you to format and display on the client side using the browser the content. And so it's an important skill. I'm not taking away from anything by saying it's not a programming language per se. And it's challenging to be good at HTML. Every bit as challenging as learning logic programming languages. But I want you to have mastery of 3. I would really like you to have a database layer. I'd like you to have a programming language, an application layer, and I would like you to have a middleware layer or a web layer. So that you can do all 3, and that is going to give you the most chance for rapid promotion and high pay. And like I said, in a down economy, you're the last one out the door because you can replace 2 other people. And in an up economy, you're the first one out the door for the higher paying job because whatever is trending up, if it's database, right now there's a huge uptick in non-relational databases, NoSQL database technologies for the cloud. So if you've got that as a strength, then you're the first one out the door for a cool new startup company that's paying big bucks and great stock options and that kind of stuff. And so I want you to have that versatility, because I can tell you this right now. If you are going to be a hands-on engineering type in IT, if you're programming or building something at the database layer, at the client layer, at the app layer, at the web layer, you are going to learn many tools and many languages over just the next 10 years of your career. You just have to. There's too much rapid change in this environment and has always been so. That being the case, you know, and if you're not afraid of change, be intentional about it and cash in on that and help it to enrich your life as well as enriching your bank account.
Of course. Can't argue that.
It's not a bad strategy. There's other takes about it. What I would recommend, that's my take on it. Talk to another IT professor, another IT professional. They're going to give you another take on it. And it's not that there's one that's wrong. You're going to find that they're different, just like investing in stocks and whatnot. You talk to all different brokers. They've all got different ideas. There are a lot of winning strategies. I can tell you that for 25 plus years, 25 plus years at this point, this has really worked well in my career, and it's worked for many of the people that I know, and it's certainly worked for some of my former students. There are other ways to approach it that are very good. This is my advice. It's free. It's worth what you paid for it.
Fair enough. Okay, I appreciate that insight, definitely.
All right. Well, we're well over time, so thank you for your patience and thank you for showing up this evening. I'll go ahead and in the recording, and I'll get this posted up to YouTube and linked into the course just as quick as I can.
Perfect.
All right. Thanks for showing up, and have a wonderful evening. Keep the questions going, and remember, I'm happy to do. We didn't cover all the parallel exercises by any means. If anybody wants to see an additional one, I'm more than happy to do a mini video by request and to link it into the Q&A discussion.
All right.
Have a great evening.
You too.